Associate Professor John Hornbuckle from Deakin University, and today I'll be taking you through an online tutorial on how to use the IrriSAT app, which provides site-specific information on crop water use. To get started today, simply what we need to do is to go to the IrriSAT Cloud App Spot and log in. So to do this, create a new tab in your browser. IrriSAT works best within Google Chrome. Simply enter the address irrisat-cloud.appspot.com and go to that website. Once you're at that website, you'll see that you can sign in using a Gmail account. Because I've signed in previously, I've got an automatic sign in there. If we sign out, when you get to that site, you'll see what it looks like here. So to be able to sign in, simply click on sign in and you'll sign in with your Gmail account. If you haven't got a Gmail account, simply go and get one by entering into your search engine, creating a Gmail account, and then following the prompts that's available. You'll be able to create a free Gmail account, which you can then use for IrriSAT. IrriSAT uses Gmail accounts to store crop-specific information that you've entered in and allows that information to be accessed through the cloud. So it can be used either through a PC or off your iPad or iPhone. So once you've entered information on any platform, it's available wherever you can access the internet, either in the field or in the office. So once you've got a Gmail account and you've signed into IrriSAT, to then get site-specific crop water use information is very simple. You'll be presented with an interface that will look very similar to this. We've actually got the ability to pan around. We can zoom out and look at the areas of interest, right out to a scale, continental scale across Australia, or we can zoom into an area that we're interested in. Today we'll be zooming into a farm near Darlington Point and having a look at some crop water use information for a cotton crop that's grown there. So to do that, simply use your mouse to zoom in and locate the fields that you're interested in. So what we'll do, we'll go down, we'll pick an image that's actually available midsummer. So if we go down and we go to February 10th, click on that series of satellite images, IrriSAT will then go and load those images into the background. What we need to do is to then show NDVI. So you can see that the IrriSAT is going and collecting those satellite images, which are being displayed on screen, and showing the crops that are irrigated. So these high NDVI values that we can see here are irrigated crops. This is midsummer. We've got the Murrumbidgee River. We've got the Murrumbidgee irrigation area to the north of the Murrumbidgee River here. Collyambly irrigation to the south here as well. So we'll just pick out a few crops and zoom in and show you how you can get site-specific information for those. So if we zoom in and have a look at this particular cotton crop, in order to get site-specific daily water use information for that crop, we need to firstly trace out that field or add that paddock to our My Fields column. So in order to do that, we simply click on this Add New Field icon up the top. Once we do that, we can then give it a name or identifier. We'll call it Paddock 1 today. And then simply go over and then with your cursor, simply then just trace out the area of the field that you're interested in. So you can do any sort of a polygon. It doesn't have to be a square shape. It can be any shape that you're interested in. Once you've traced out the corner points, click back on the starting point and you'll see the polygon's closed, and we've then got the ability to add that field to IrriSAT. If we just give it a few seconds there, that field will then be added to your My Fields, so you can see that's increased by 1, and then that field is then available to display information on. So what we've got here as well, we can display the normalized difference vegetation indices. We can actually fade those in and out as well if that's easier for us to actually identify a field through that technology as well. We can also highlight the crop coefficient, so we can have the crop coefficients showing that are determined by those satellite images for those fields that we've traced out as well. Values for crop coefficients are shown over here on the right hand side, varying between 0 to 1.2, and NDVI values between 0 and 1. So you can see some variability in these fields here. that are associated. This field that we're actually interested in here, we can see some variability across that as well. Some slightly weaker areas with these lighter crop coefficients, and slightly stronger areas with these higher crop coefficients up in this part of the field. What IrriSAT will do is use an average KC to get site-specific water use for that area across the field. So if we actually just click on that field now, what IrriSAT will do is actually go away. It'll then collect those satellite images over the time period that we're interested in, and then display those images, which we'll see in this crop growth chart at the top in a second, as well as a daily crop water use in the bottom chart as well. So we'll need to give it a few seconds there. It's actually going back, getting a whole series of satellite images that's been available over the last while that we're interested in, and that'll display those. So what we can see here, we've got the winter period. We've got basically a fallow that's been on this particular field, a very low crop coefficients. We've then had a plant of cotton around about late October. That cotton crop is then grown. You can see we've reached a mid-season crop coefficient, slightly over 1 there, around about 1.05. And then we've started to SNES off once we've gone into defoliation periods as well. So in this top graph, what we've got is field visibility that you can see through the satellite. So you can see we've got very good field visibility, 100% at these periods here. We've got a period here where you can see we've got a slightly decrease in calculated crop coefficient, and you can see that we've probably got some cloud cover in there as well, so that's probably affected that individual reading. What we can also do is focus this information up just to have a look across the growing season. So if we click on this field settings tab here, we'll define the period that we're interested in. So if we go for a planting date of, say, late planted crop, say 26th of October, and then we'll put in a harvest date as well, just allow us to tighten up those graphs. And we'll say it was harvested on Thursday, the 31st of May. Once we've got that in, if we just apply those two planting dates, we'll then change our reference ET, so our reference weather station. We can either have nearest available source, which is a couple of weather stations near Darlington Point, or the local Griffith weather station in this case, which we'll go with. The other option there as well is the silo experimental data set, which is available as a grid-based reference right across Australia, which is a good option if you don't have a consistent local weather station. Once we've done that, we simply click apply. We go back to our crop health charts that we've shown before, and you can see that those charts are focused up on looking at the growing season that we're interested in. So as I mentioned, this top chart shows crop growth. So you can see the crop coefficient it rapidly increases over that December-January period, reaches a peak around about mid to late January, and then stays fairly consistent until the crop starts to senesce off, and we're starting to apply defoliations around about mid to late April. You can see in this bottom graph what we've actually got is the accumulation of the crop coefficients, which is site-specific for that particular field, combined with the weather station information. So you can see these blue dots are actually daily crop water use over time on each individual day. So you can see we get a peak there of around about 13.4 millimetres during the last irrigation season on an individual day. That's the highest water use. When the crop's very young, we've got water use down around just under 1 millimetre per day when it's very small. What we've also got in the background is cumulative water use here as well, shown as this green shaded area. So that's accumulated on a daily basis. So you can see over the growing season, around about 850 odd millimetres, or 8.5 megalitres per hectare was evapotranspired on this particular crop. So it's a very quick introduction to using IrriSAT to get site-specific crop water use information. What we'll do is come back in the next series of online tutorials and show you how we can also use this as an irrigation scheduling tool as well. So stay tuned for the next installment. Thank you.